treatments for patients with some diseases, okay? This is made in multidisciplinary teams with clinical doctors, nurses, with lab technicians, with investigators, and we need patients, of course, with some kind of diseases that we are interested in study, and we need healthy individuals without that disease. And then we collected biological samples, and it can be urine, blood, brain, and we study molecular differences between the patients and the controls. I started by working with DNA. You all know what it is, DNA, right? Yes. Yeah. So, what it is DNA? What it is DNA?
Frederico. Carolina.
Our genetic code, yeah. It is the molecule that has the genetic information of our body that is necessary to be I am like I am because my DNA, you are like you are, because you have a different DNA from mine. And this is useful to study these genetic markers, and not only genetic, but mainly genetic markers, to future applications in a better management of patients. And based on this, I made my final internship, and I did my PhD thesis in genetics of epilepsy. And I must say it was a frightening moment, and it was also the proudest moment of my life. It was my goal since I was your age to have a PhD in science, so I'm here with all my examiners. It was a very frightening moment. And nowadays, I continue my work in the laboratory. I work in ICBAR, in Universidade do Porto, and today my job is to find biomarkers for immune-mediated diseases, not only epilepsy, but for instance, multiple sclerosis and psoriasis. And for that work, we have already won a prize this year. And what it is biomarkers? It is characteristic that is objectively measured and evaluated and can give us the state of a body, okay? So, if I am sick, this biomarker, this particular molecule, has to be able to give me the information if that person is sick or it is healthy, okay? But it can be measured with objectively, okay? I cannot say, well, it is 1, and you go and analyze it and say, no, it is 2, okay? It has to be a precise measure, okay? And it allows us to predict the development of the disease, to measure the progression of the disease if it is already established, and can be used to create animal models that are more specific to study that disease. Because, and I'm going to make here a parenthesis, because you may ask, why not to study animal models of the diseases, and why to study patients? Animal models are perfect. They are raised, they are born and raised in facilities. They are not subject to environmental changes that patients are. It is perfect to have animal models to study a disease in some molecular aspects, because I cannot go and take the brain of multiple sclerosis patients, okay? But I can take the brain of a mouse. And that is perfect to understand the development of the disease, some mechanisms. But it is not, does not allow us to know what it is the difference between one patient and the other, because patients have different evolutions of the diseases, okay? So it is not possible to study that animal models for that. And with this objective to study these biomarkers, it is to find methods that allow us an early detection and a prevention of the disease development, and also to have more specific and better treatments for patients that respond differently to these treatments. And the objective is to improve the quality of treatments and to improve the quality of life of these patients. And it is that I work for. I don't believe I will have a Nobel Prize for this, but I am happy, and this is a great achievement to me, to know that I can make the difference in the life of these patients, because this has really an implication in the life of the patients.